Good morning, Algebra 1 students. Today we're going to be looking at Lesson 49 together. Before we actually start there, though, I want to make sure you have your packets and you have your books. Lesson 49 starts on page 197. You can go ahead and open your books because I will need for you to focus on a rule that's written there in just a little bit. And then, of course, you'll need it for your problem set. Excuse me. Before we start with 49, I just want to go back to what we talked about yesterday in class, which was on lesson 48. We talked about polynomials. So let's just kind of review what a polynomial is. Remember that a polynomial is simply an algebraic term. It may have degrees on it. It's going to have degrees on it. We can tell the degree of a polynomial and we can tell the degree of a term. So let's kind of review that for just a moment. Look down here at number 1. This should be in your packet already done. But number 1, we had to name this polynomial based on its number of terms. So we're going to look at the terms, how many there are. I see 1, 2, 3, 4 terms. So here's a polynomial that has 4 terms and its degree. And remember, first of all, we can tell the degree of a term by adding the exponents that you see in the term. So here we have an exponent of 4. Here we can add those together for 5. So we would say the highest degree term is this term right here. But as far as the degree of the polynomial, which is what this question is asking, we have to figure out which is the highest degree term, which happens to be this one here. So 5 is the highest degree term in this polynomial. So this is a 5th degree polynomial. It kind of sounds like a lot of jargon and can make it confusing, but it's really not confusing if you think about how many terms are in the polynomial. There's 4 terms in that polynomial. What's the degree of the polynomial? Find the term that has the highest degree, and that is the degree of your polynomial. Now let's bump down to lesson 49. I'm going to add a sheet here because I'm going to show you some things before I have you actually build into your notes. There we go. Not exactly where I wanted it, so let me go back up here. There we go. All right, so we're going to start off by looking at something that you guys already know. This lesson is going to be mostly about how to distribute and multiply polynomials. So you'll recall with me that first of all, in looking at a literal equation that we've already seen in the past, in order to distribute this, you guys would say, okay, I'm going to take A times B, and then I'm going to take that A and multiply it with the C. And then we add those terms together. Okay, so let's look at an example that might have some named terms here. Let's look at this example. This is actually coming out of your book. It's 49.1. You don't have to write this down unless you love to take notes, then you can certainly write it down. In this example, and I feel like we've already been doing some of this, the only thing I want you to be cautionary about is how do I handle these exponents when I multiply? So remember that, because this is like x times x times x, which we know is going to be x to the 3rd power. Okay, so we do this distributing process just like we did up here in this example. I'm going to take 4x and multiply it with 4x squared, and I would get 4x to the 3rd power. And then I take 4x and I have to distribute it to this 2. This is subtraction in here, so we keep that going on. And we have 8x out to the right here. That would be your answer once you have distributed the 4x to each term within the parentheses. Now let's look at something a little bit harder, and I still feel like we've been doing some of these. If we have a plus b times c plus d, what this means is I'm going to have to take this a plus b and distribute it with both the c that's in this set of parentheses with the d that's in the set of parentheses to the right. So we're taking this term and multiplying it with every term in the second set of parentheses. So you end up with AC plus BC plus AD plus BD. Okay, now why does this work, you might ask? So I'm going to take these two here, and I'm actually going to build a problem that would be very, very simple. This is going to be an easy example. So if I had 2 plus 3 times 4 plus 5, for example, you would know if I used PEMDAS, the order of operations, to solve this, I would say I have 5 times 9 equals 45. So we know our answer should be 45. But what if I wanted to distribute this instead of actually just calculating what's inside the parentheses first and then multiplying? What if I distributed this? I would take my 2 and distribute it to the 4. I would take my 2 and I would distribute it to the 5. Then I would have to take my 3 and distribute it to the 4. And take the 3 and distribute it to the 5. And hopefully what you're picking up on is that when you distribute terms, each term in the first set of parentheses has to be distributed to each term in the second set of parentheses. And eventually these are going to build. So you're going to see that you're going to have more quantities that you're going to be, or expressions, if they have variables in them, they're expressions you have to multiply with each term within each set of parentheses. So here we would have 8 plus 10 plus 12 plus 15, and if you stuck that in your calculator, you're going to come up with 45. Okay, so either method actually works. So this brings us to our rule that I want you to look at on page 197. Oh, just under halfway down. It says the rule for multiplying polynomials. Here's the rule. To multiply one polynomial with the second polynomial, each term of the first polynomial is multiplied by each term of the second polynomial, and then the products are summed together. If it's a subtraction problem, like it was up here, where I'm drawing a little star, actually highlight it in orange, okay, where it was subtracted, then you would subtract, which is like adding a negative number, right? So when you see the word sum, it's adding a negative number. But we kind of talked beyond that now. We don't really say adding negative numbers, we just know it's subtraction. So here's an example. This is coming from, oh, wait a minute. Before I do this one, I'm going to write it here, but I'm going to go up, and you're going to look in your packets with me now. We're going to complete examples 1 and 2. Oh, I got really out of whack here. Here we go. Okay. All right, so let's look here. So we have a monomial, right, because there's only one exponent of 1, or one, I'm sorry, there's one term. 3x is one term, multiplied by a binomial, because there are two terms here. All right, how do we do this? Well, we just did a couple of these examples a moment ago. So we're going to take the 3x, and the 3x has to be multiplied with every term within this set of parentheses. So we do 3x times 2x, and you're going to end up with 6x squared. Then we take the 3x and we multiply it with the 4, and you're going to end up with minus 12x. And that is the answer to number 1. Very simple. Now let's try number 2. Same idea, taking a monomial, multiplying it with a binomial. So we take 5x squared and we multiply it with 2x, and we get 10x to the third, because remember that we add our exponents, minus, and we have to multiply 5x squared with 4x to the fourth. So 5 times 4 is 20. X to the second power times x to the fourth. We just add our exponents. 2 plus 4 is 6. And that would be the answer to number 2. So there's 2 nice little examples in your notes for you. Now we already kind of talked about how to multiply when you have a binomial times a binomial. But let me go back up to find my sheet, because I'm going to do a couple examples with you here. Okay, so this is coming from 49.2. That is in your book. And you can just watch here. If you want to write it down, that is completely up to you, but you can just watch me work through this. Okay, so what this says is if I have a binomial times binomial, I want to multiply every term that's in the first binomial with every term that's in the second binomial. Okay, there is something that's called the FOIL method. And the FOIL method is most commonly used when you're doing a distributing problem with binomials or trinomials or any setup that you might have. The FOIL method is really handy. What it means is you're going to multiply your first terms with your outside terms, your first two terms, and then your two outside terms. The I is your inside terms, and the L is your last terms. So let me show you how that works. Now my lines get a little messy. I'm going to use two different color lines, and mine will tend to get messy because I like to do all mine underneath, but the FOIL method shows doing some of them on top. So I think what I'll do is I'll show you how they're done when you actually, in your notes, there's a sample here for you. So let's do our first terms first. So I'm going to take 4x times 3x, and I'm going to get 12x squared. And then I'm going to take my outside terms underneath here and multiply those minus 8x. And then I'm going to take orange and I'm going to multiply my inside terms, which are, my inside terms, which are right here. And I'm going to have 15x, and then I'm going to multiply my last terms right here. See, I can't even do the ones up top. I don't like to use it that way, so my brain automatically goes this way. But so we're going to have minus 10 here. So actually, I should have done, just to kind of make this a little neater, let's do this. So my last terms would be here. That way you'll see it a little bit better, minus 10. Okay, so now we'll just add together what terms are like terms, and I can see here that I've got a few. Right here, actually just 2. So our final answer would be 12x squared plus 7x minus 10. Okay, so that's how you would do that. Now let's look at problem 3 and 4. You've got a couple, and keep in mind too, if you have a lot of terms with different exponents on it, you're going to want to write those in descending order, and you need to start doing that now as part of your assignment. So let's look here. We have the FOIL method, and you can see here's how it works. Off to the left over here is the FOIL method written for you. Now, I do all my lines underneath. It's just easier for me, but what I can do is try to at least do different color lines so you can kind of follow me. If you like the way it's written on the left here and you like doing the lines on top, it's up to you. That's completely fine, but the point is just keeping track of making sure that each term in the first binomial gets multiplied with each term in the second binomial, okay? That's the key. So let's go ahead and work this out. So we have first terms, which would be x squared. Outside terms, which would be minus 2x. Let me change my pencil. Then I take the inside terms, 3 times x, and I get 3x. And then I take 3 times 2, negative 2, and I'm going to get negative 6 or minus 6. So I have a couple terms here that I can put together. Those would be these two right here. So my final answer would be x squared plus x minus 6. Let's try number 4. It's the same type of a problem. Again, I'll change up my color so you can follow what I'm doing. And you can try it. If you want to pause the video and try number 4 on your own and see if you come back with the same answer I do, you are welcome to do that. I'm going to go ahead and continue on. So I have my first terms, which are 3x times 2x. I'm going to have 6x squared. Take that first term again and multiply it. So these are my outside terms, minus 15x. Then I'm going to use my negative 7 and multiply it with 2x. I'm going to get negative 14x. Those are my inside terms. And now for my last terms, I have positive 35 because I'm multiplying a negative 7 times a negative 5. Again, it looks like I have like terms right here. So my final answer is going to be 6x squared minus 29x plus 35, and that's the final answer for number 4. Okay, I want to look at another example problem with you. Let me get back up to my sheet up here where I was writing. Okay, this is going to be 49.5 is the example number in your lesson. If you saw a problem that looked like this, 3x plus 2, and it's squared, you need to know that you're not going to just go, oh, 3x squared is 9x squared plus 4. That's not the correct answer. What you need to do here is recognize that 3x plus 2 is being squared. So it'd be like if you had 2 squared, you know that that would be 2 times 2. Well, the same is true here. It's 3x plus 2 times 3x plus 2. And then you just solve this using your FOIL method. Okay, now I'm going to bump to 49.6 because now it gets a little bit harder. We're going to take a binomial and multiply it with a trinomial. So it is 4x minus 2 times x squared plus x plus 4. Okay, so your lines can get a little messy here, so I will try to do some on top and some on bottom. But I'm going to look at my first term first. I'm going to take 4x. Remember, I can't say it enough. Every term in this binomial has to be multiplied with each and every term in the trinomial. Okay, so I'm going to start with the 4x. 4x multiplied with x squared is 4x to the 3rd power. 4x times this x, positive x, is going to be plus 4x squared. 4x times 4 is 16x. It's positive. Now I'm going to change the color, and I'm going to do these on the top for you. Now I have to take the second term, negative 2, and multiply it by each term in the trinomial. So I'm going to have minus 2x squared, so it's going to get a little long on you. Then I take negative 2 and multiply it with the positive x. I'm going to have a negative 2x. Take that negative 2 and multiply it with the 4. I have minus 8. So the final answer here is going to be, I've got to find if I have any like terms, and I do. I have a 4x squared and a negative 2x squared, and I also have 2x terms here, a 16x and a minus 2x. So let's write out what we have as our final answer. So I have 4x to the 3rd power. My x squareds are 4x squared minus 2x squared is a positive 2x squared. My x's, I have 16 minus 2, which is 14x minus 8. And notice that my exponents are in descending order. The exponent of 3 comes first, it follows with an exponent of 2, and then finally an exponent of 1, and then our whole number 8. So that is the final answer to multiplying a binomial with a trinomial. Now let's go do number 5 in your packet, and then we're going to move on to the practice problems. Number 5, basically using the FOIL method, but the difference is you have an extra term in your trinomial. But if you keep in mind this rule, every term in my first set of numbers, so in this binomial, has to be multiplied with every term in that trinomial. So if you want to pause the video and work it out and come back and see if you got the right answer, please feel free to do that. Or if you're still a little unsure, you can just stay with me as I work it out together with you. So 2x times x squared is 2x to the 3rd power. 2x times the negative 9 is minus 18x squared. Actually, it's 9x squared, 9x, excuse me, I didn't say that. 2x times the negative 9x is negative 18 squared. Take the 2x and multiply it with the positive 3, you get plus 6x. I'm going to change the color here, and we're going to go 4 multiplied with x squared. You're going to have 4x squared. Take the 4 and multiply it with a negative 9x. You're going to have minus 36x. And finally, take that positive 4 and multiply it with that positive 3, and you end up with the positive 12. Now let's find our like terms. We only have one x to the 3rd term. We have 2 x to the 2nd power terms. I'm going to highlight those instead in yellow. So we have a negative 18x squared, and we have a positive 4x squared. So let's write down what we have already. So we have 2x to the third power. Remember, we want to write these in descending order of exponents. And we have minus 18 plus 4, which is going to give us a negative 14x squared. Let's highlight the next ones that have a commonness here. I'll use green. I see two x terms here. I have a plus 6x and a negative 36x. So let's put those together. Negative 36 plus 6 gives you a negative 30x. And the last term is that 12 over there. So what your answer in finality would be 2x cubed, or 2x to the third power, minus 14x squared, minus 30x, plus 12. Okay, if you would like to pause the video and try the 3 practice problems, you can find those on page 199, A, B, and C. Give those a shot. I'm going to go ahead and do them here. If you want to stay tuned with me, you can, or you can pause the video, try them yourself, and then you can scroll to see, when you come back into the video, just scroll over to where the answer is and see if you did it right. If not, then you can rewind it back to follow how I did those problems. So the first problem is 5x plus 3. These are two binomials, 2x minus 4. I'm going to use the FOIL method here. I'm going to use 5x times 2x. I'll have 10x squared. 5x times a negative 4 is minus 20x. 3 times 2x is plus 6x. And 3 times a negative 4 is minus 12. I will put my like terms together, and I will have 10x squared minus 14x minus 12. That is the answer to letter A. Letter B. Letter B says we have 5x minus 6 squared. We know that means 5x minus 6 times 5x minus 6. And we'll use the FOIL method here as well. 5x times 5x is 25x squared. 5x times a negative 6 is minus 30x. Negative 6 times 5x is minus 30x. And negative 6 times negative 6 is a positive 36. I have two x terms here that I need to put together. So I have 25x squared minus 60x plus 36. That is the answer to letter B. And then finally, the last example is taking that binomial and multiplying it with a trinomial. So remember, every term in your binomial must be multiplied with every term in your trinomial. So I'll start with my 3x, and I'll multiply it with x squared. I will have 3x to the third power. 3x times a negative 2x, and I will have negative 6x squared. 3x times that positive 3 will give me a positive 9x. Let me use a different color here. We'll take pink. Now I'm going to take the second term in my binomial and multiply it with each term in my trinomial, and I'll use a pink one here. So we have negative 1 times x squared, which gives us a negative x squared. Negative 1 times a negative 2x gives me a positive 2x. And negative 1 times that positive 3 gives me a negative 3. So let's see what I have that I can put together. I'll use yellow to indicate those. I have a negative 6x squared and a negative x squared. I'm going to go ahead and start writing down what the final answer is going to be. So I have 3x cubed. I put these terms right here together, and I have a negative 7x squared because it's negative 6 plus, there's like a negative 1 here, right? Negative 6 and a negative 1 is negative 7. The term is an x squared term. Now I see that I have a 9x and a 2x, both positive. So I'm going to have a plus 11x here, and and our last term was minus 3. Again, notice the exponents are written in descending order. So the final answer is 3x cubed minus 7x squared plus 11x minus 3. And that is the lesson for today. I hope that all made sense to you and you might enjoy actually doing some of these problems today. If you have any questions, of course, you know that you can reach out to me through Google Classroom or directly to my email. Either way, I will get an email from you. Happy Math on Friday. I hope you guys have a great weekend once you get all of your homework done. All right, guys, have a great day. Bye-bye.